Hey everyone, this is Meryl from Meryl's Magic Math, and I am here today at Harrison College with some students in a math class, and I'm talking to them about real-life math and why do you learn math. So you won't see them, you'll just maybe hear if they put in any feedback, but if you have any comments, feel free to leave them throughout this. So without further ado, I'll introduce myself. All right, so I'm Meryl Weaver. I have experience teaching middle school, high school, and college students, and then I decided I'm going to reach out and start my own business. So I now tutor students, both in person and online. So I was just at the library down the street, and so I thought I'd pop by and say hi to you guys. So the longest teaching stint that I had was down in Atlanta, and I taught AP Calculus. And in almost every lesson, a student would interrupt me and say, when am I going to use this in real life? And I mean, it's a valid question because automatically when you learn something new, your brain decides, is this worthwhile remembering? Am I going to use it in the future? Because if you're not going to use it, your brain's going to forget it. So unfortunately, to answer those students' questions, a lot of times, unless they were going to be engineers or in the STEM field, they probably wouldn't use calculus. So why would they sit in my class? Why are you guys sitting in this class? Other than, I mean, a lot of times for both high school and college, you're forced to be in a math class. And I think that really boils down to problem solving. No matter what job you have, you're going to be asked to complete a task, to get to some end goal. And likely your boss isn't going to say, okay, step 1, do this, step 2, do this, step 3, step 4, step 5. Because if they were going to take the time to do that, they probably would have solved the problem themselves. So really the focus of today is going to be this problem solving and real life applications of math. I'm going to tell you a problem that I solved recently myself, and have you guys solve some problems. So I give you those handouts, and then at the end I'll go over some problems that if you're able to solve will earn you $1 million. Okay, so before we jump into math, I know you guys have been doing some math, so I'm going to give you a break and tell you about some math that I've been doing. So, and a little bit more about me too. So recently I've been dating, and I don't know if you guys are in the same boat as me, but if you are, you probably realize that online dating is the way to go. So after you do some swiping and matching and talking, and then you finally set up a date, I don't know. So I had a date set up, and we continued to talk prior to meeting for said date, and she realized that I am a big math nerd. So she told me a math problem she's been trying to solve, and the problem is that she is on a planning committee for a big festival, and she needs to figure out how much alcohol to purchase she's in charge of the mixed drinks type of thing. So the issue is she wanted to do 3 different drinks, and she has 10 different of these 13-gallon coolers. They had to be dispersed around I think 3 different stations throughout the park. And so far, it's not too much math. It's more decision making of which drink is going to be most popular, put that at the most popular station, and kind of going from there. But what you need to think about, and I definitely saw how she was overwhelmed, was thinking about how much liquor does she actually need to put in each of these coolers. I mean, you have to have the alcohol and the mixer being of equal ratio. Well, maybe not equal ratio, but a good ratio such that if it's too strong, she's gonna lose a lot of money. If it's too weak, people aren't gonna buy it, type of thing. So here she comes up to this first date with a notebook in hand and some spreadsheets, and we solved this math problem. So dream first date, right? I mean, for me maybe. So I was looking through her work, and all of the calculations were correct. She was doing this division where she needed to, setting up proportions, all the things that were giving her the correct numbers, but sometimes she wasn't exactly sure what the numbers meant. So what is this? So if you divide this by this, you get 12.23. What does that actually mean? And really the benefit of math and problem solving is figuring out, does this process make sense? Is the solution correct? And what does the solution mean? So a lot of times in math classes, you learn a procedure, you do it 10 times, and you're like, oh yeah, I understand it. And you usually forget it 3 weeks from then. But really, again, this is worth reiterating, math is about problem solving, figuring out, does this process make sense? What is the solution, and what does the solution mean? And one of the most interesting parts, I think, to me at least, of that problem was thinking about, so she had a 12-ounce cup, and she's going to fill these cups with obviously the drink. So if you have let's see this here. You get to see my art skills as well as my math skills. Okay, so if we have a 12-ounce cup, and obviously you're gonna first fill it with some ice, right? So what do you guys think? How much liquid are you gonna fill? Okay, so this is gonna take way too long. So you got some ice in there. So how many ounces do you think will the rest of the cup fill?
About 8.
About 8?
Just 8.
I like that. What do you like 8? Do you have a different suggestion?
It depends on how much ounces the water and the ice is.
Right. So would 2 make sense at all?
Yeah.
Okay. How about would 12 ounces make sense?
No,
Why not?
because one, if it's ice, then it's going to be overflowing.
Yeah, exactly.
2, that won't leave any room for the alcohol.
Right. I mean, even if there wasn't any ice, 12 would be up to the very top. You're gonna be spilling it on the people behind you. Like it's gonna be a bad situation. I like 8. I mean, 8, 10 depend, like exactly like you said, depends on how much ice you're gonna put in. So I'm gonna take a guess here and think that nowhere along the lines did a math teacher say, hey, you have a 12-ounce cup and you put ice in it, that you're gonna put in about 8 ounces. It's just the problem-solving skills that you've developed. So kind of like the big point of the story is that math is more than just taking a process and doing it a million times. It's problem solving, it's estimating, it's reasoning. Does this make sense? Why would this be too small or this be too big? And even if you aren't necessarily on a planning committee for a big festival, maybe you can impress a date with some math skills like I did. So. All right, so that's probably way too much information about me. Tell me about you guys. How do you feel about math? Do you like math?
No.
Not so much?
I kind of like math, but it never works for my plans.
I like that. So you start off and you're like, this is gonna be great. I'm gonna excel in this, and then sometimes it kind of falls off the rails a little bit.
For some period of time, I've been trying to do my expenses and trying to create a budget, and I never end up getting there.
Oh, sticking to the budget's hard.
Yeah.
Absolutely. Especially, I was really excited today. I got gas at $2.18, then everywhere else was $2.55. I was like, thank you. It's like the accomplishment of the day. But okay, so other people, I saw some shaking of the head of no, not liking math. Why not?
I'm just fine good at it.
Like, not good at math. Okay.
Most of it, like you said at the beginning, most of it I don't need anymore.
Okay.
That was cool.
Mm-hmm.
Getting back into it's just like aggravating.
Yeah. Right, because it's been so long since it's been out of your brain that you're like, gosh, I knew how to do this at one point, and then just getting it back. Okay, that makes sense. Okay, so I'm gonna be honest. I don't think in the next 45 minutes I'm gonna change your mind and be like, oh yeah, math is amazing. Everyone should do math all the time. But maybe I can change your perspective a little bit, and maybe you can see it. So I if you heard myself earlier, I call myself Meryl's Magic Math, my business, because I really think that math is magical if you kind of can see all the connections and how it's all related. So. Okay, so I'm gonna go with what you said about being not good at math. So think about something you are good at. So I don't know, maybe it's writing or sports or video games or dancing or singing or I have no idea. So you don't have to tell me what it is, just have something in mind. Okay, so were you always good at that thing? And maybe you were naturally inclined to excel in it, but I'm sure you've gotten better over time. And why do you think that would be?
Just
Practice. So have you given math enough of a chance? Did you put in enough practice and time and effort? And I know
at least 12 years.
I know it might not be as exciting as that other thing, but
it's hard not to use math because you use it every single day.
Mm-hmm. And kind of exactly, you do use math every day. It's not necessarily to the level of, hey, I'm going to be finding the area of a circle or using Pythagorean theorem, but some of the basic stuff like percentages or budgeting is absolutely going to come back every day. Perfect. And I came across this. So as I have been kind of starting my business and in the last year and so, I've been trying to expand and do online tutoring. So my number one goal right now is to be on page 1 of Google for online calculus tutor. So in order to do this, you have to learn SEO. Have you heard of this? Search engine optimization. And that's exactly where I started. I was like, SEO, like I heard that somewhere, SEO. I'm like, what is SEO? So I like Google, like, what is SEO? And I realized like I am so far behind in this. And after I got up all these videos and articles, I'm going to learn SEO. I'm going to be an SEO champion. And after like 2 days, I was like so overwhelmed. I was like, this SEO is not for me. I'm not doing this. And then I came across this TED Talk. I'm gonna show it to you, and it's about the power of yet and the power of thinking you can improve. And so I'm thinking maybe you guys can apply it to maybe not even or to math, yes, but perhaps other areas of your life as well. And I had to apply this for my SEO of, hey, I don't know what SEO yet. So we'll see if it loads here. And so this is Carol Dweck, and a lot of the research she does is with children, but I obviously just told you I kind of applied it to my life, and I am not 10 years old, as some of her research is. So take that with a little bit of a grain of salt. Let's see if we won't watch the whole thing, but.
The power of yet. I heard about a high school in Chicago where students had to pass a certain number of courses to graduate, and if they didn't pass a course, they got the grade not yet. And I thought that was fantastic, because if you get a failing grade, you think, I'm nothing, I'm nowhere. But if you get the grade not yet, you understand that you're on a learning curve. It gives you a path into the future. Not yet also gave me insight into a critical event early in my career, a real turning point. I wanted to see how children coped with challenge and difficulty. So I gave 10-year-olds problems that were slightly too hard for them. Some of them reacted in a shockingly positive way. They said things like, I love a challenge. Or, I was hoping this would be informative. They understood that their abilities could be developed. They had what I call a growth mindset. But other students felt it was tragic, catastrophic. From their more fixed mindset perspective, their intelligence had been up for judgment, and they failed. Instead of luxuriating in the power of yet, they were gripped in the tyranny of now. So what did they do next? I'll tell you what they do next. In one study, they told us they would probably cheat the next time instead of studying more if they failed the test. In another study, after a failure, they looked for someone who did worse than they did so they could feel really good about themselves. And in study after study, they have run from difficulty. Scientists measured the electrical activity from the brain as students confronted an error. On the left, you see the fixed mindset students. There's hardly any activity. They run from the error. They don't engage with it. But on the right, you have the students with the growth mindset, the idea that abilities can be developed. They engage deeply. Their brain is on fire with yet. They engage deeply. They process the error. They learn from it, and they correct it. How are we raising our children? Are we raising them for now instead of yet? Are we raising kids who are obsessed with getting A's? Are we raising kids who don't know how to dream big dreams? Their biggest goal is getting the next A or the next test score? And are they carrying this need for constant validation with them into their future lives? Maybe because employers are coming to me and saying, we have already raised a generation of young workers who can't get through the day without an award. So how can we build that bridge to things we can do?
So she talks essentially a lot of implications for teachers of helping people talk about
Give kids greater confidence. Give them a path into the future that creates greater persistence. And we can actually change students' mindsets. In one study, we taught them that every time they push out of their comfort zone to learn something new and difficult, the neurons in their brain can form new, stronger connections, and over time, they can get smarter. Look what happened. In this study, students who were not taught this growth mindset continued to show declining grades over this difficult school transition. But those who were taught this lesson showed a sharp rebound in their grades. We have shown this now, this kind of improvement with thousands and thousands of kids, especially struggling students. So let's talk about equality. In our country, there are groups of students who chronically underperform. For example, children in inner cities or children on Native American reservations. And they've done so poorly for so long that many people think it's inevitable. But when educators create growth mindset classrooms steeped in yet, equality happens. And here are just a few examples. In 1 year, a kindergarten class in Harlem, New York, scored in the 95th percentile on the National Achievement Test. Many of those kids could not hold a pencil when they arrived at school. In 1 year, fourth grade students in the South Bronx, way behind, became the #1 fourth grade class in the state of New York on the state math test. In a year to a year and a half, Native American students in a school on a reservation went from the bottom of their district to the top. And that district included affluent sections of Seattle. So the Native kids outdid the Microsoft kids. This happened because the meaning of effort and difficulty were transformed. Before, effort and difficulty made them feel dumb, made them feel like giving up. But now, effort and difficulty, that's when their neurons are making new connections, stronger connections. That's when they're getting smarter. I received a letter recently from a 13-year-old boy. He said, "Dear Professor Dweck, I appreciate that your writing is based on solid scientific research. And that's why I decided to put it into practice. I put more effort into my schoolwork, into my relationship with my family, and into my relationship with kids at school. And I experienced great improvement in all of those areas. I now realize I've wasted most of my life. Let's not waste any more lives, because once we know that abilities are capable of such growth, it becomes a basic human right for children, all children, to live in places that create that growth, to live in places filled with yet. Thank you.
So I like that it kind of focuses, I mean, you've probably heard like positive mindsets in general, like the more optimistic you are, the better the outcome usually is. But any reflections on that? Did you like it or interesting?
I did like it, and I don't think it's only just kids.
Right.
I've seen a lot of people. I work at a place where sometimes I have to train the people coming in.
Mm-hmm.
And there's a lot of people that they really think they can do it.
Right.
And I went like, I wouldn't be asking you if I wouldn't think you're capable of doing it.
You can't do it yet, but give it some time. Absolutely. And think about like what has been your greatest accomplishment so far. What are you most proud of in your life? And did that come easy? It probably wasn't a big accomplishment if there wasn't a little bit of struggle, right? And kind of makes the success even more sweet in a sense. Okay, we ready for some math? Let's do it. Okay, so I came up with two different problems, and you guys can kind of choose which one you look at. And really, I came up with some examples first of math in real life, and these are a lot of comparisons. A lot of times, like comparing which coupon is better, which we're going to look at today. Is it better to buy an annual pass versus a monthly pass at a theme park or a ski resort? Is it cheaper to drive to the gas station down the road to get that lower rate? Most of the time it's not. But are there any problems you've come across recently, like other than like math problems, like more like real life problems that you're like, I wonder how to do this. I don't know that I have the skill set.
Yes.
Yeah?
I was trying to become a couponer for some time.
Uh-huh.
I'm still trying to,
Okay.
But it takes some time, and like you said, like study the coupons. When will you be better to use them?
It sounds like you want to do the second one then. Perfect. Well, and I was going to say the kind of the thing about that problem is, so I'll even go to this here. So the first problem is a car question, and then the second one, which coupons is going to save you more money with the 30% off the entire purchase or 40% off one item. I mean, I'll be honest, you can cheat a little bit and just take both and maybe have the cashier ring it up. But I will show you the math behind it. So that problem I'm a little bit less excited about. I like the car problem more. Not right at the computer. So the car problem I liked, and I actually looked into this myself when I was buying a car a couple of years ago, of which would be cheaper down the road, a regular gas LE or a hybrid. Because if you look at the MSRP, so the manufacturer suggested retail price of the LE is a lot cheaper, so it's $22,000 compared to almost $26,000. But the hybrid gets a lot better gas mileage. So you have to pay, so you'll pay less in gas, and it's kind of like, when will they become equal? When is it going to be better to have the hybrid after how many years? So we can kind of look at either of those two questions. And so I'm going to say goodbye to my Facebook Live friends. We're going to take a break and solve some of these math problems, and might catch you in a little bit.